Hey friends, Tyler Vanderhoeven here again. Today we're going to look into how to upload a contract to a Turing signing server. So there are several Turing signing servers that I've already set up, and today we're going to look at how to build a contract and upload it to a Turing server for usage. So the first thing we're actually going to need to do is actually have a method for compiling from the JavaScript file we're going to write, the contract we're going to write, to a compiled version, which is fully executable on its own as a component, if you will. And I actually have that built into the Turing signing server repository. So you don't need a Turing signing server to do this. You're going to be uploading it, so you could strip away all the parts that are not related to this contract piece, but we have this webpack config.contracts, and then we have a contracts source file. So I've got some logic built into this repository which will allow us to compile a contract down to a single executable. So we're going to go ahead and clone this. Git clone is going to be on my desktop. Change into that directory, npm install everything. We're not going to be running any servers or anything. We'll just be using this repository to build our contracts. Once that finishes up, we'll go ahead and open this repository in our code editor, and we can close that out now. So what we're going to be dealing with here is our contracts source directory. We've got some contracts already, kind of helper contracts, demo contracts built in here. We're actually going to be rebuilding this filter contract. And then the webpack here is what we'll be using to execute from source to a distribution directory from our contracts source folder. And we'll be using the contracts production script to run that. Let's go ahead and pop into our filter here. It's kind of got some boilerplate code in here which we'll fill in as we start to write out our contract and then deploy it after we compile it. So the contract's actually incredibly simple. This is a filter contract, which essentially what we're trying to do is build a contract that we can attach to an account, which will only sign for transactions if the payment is below, the XLM payment is below whatever we set here. So essentially we've got a request that's coming in, which has this XDR, which will contain, has to contain just one operation that is of type payment, whose asset is an XLM asset, and whose amount is less than 100. This is greater than because if it's greater than 100, it will reject the transaction. So if it's 100 or less, it will continue on so long as all of this is not true. But if any of these are true, the request will be rejected and the payment will proceed on to the signing piece. If it's all good, if everything checks out with the request, the incoming request's XDR, we can move into the turret section, which adds the fees, the Turing fees that we pay to the Turing servers once they sign the transaction. And so those are attached to the XDR, which we submit here, and it's spat out at the end as a XDR, which, so long as these fees are correct, the Turing server will sign this transaction with its signing key that it will assign to this contract once we upload it. So this would be our contract. This is actually all ready to go. We'll fill in these details. These are just comments which in the future will help us remember the different sort of demo details that we might need for this contract. So the first piece we're actually going to need when we upload it is a contract address, and this is only going to be used to help us with updates if we need to change the turret addresses, which are the Turing signing servers which we will be uploading this contract to. So this helps us discover who all is storing this contract. So when we go to do a collation for this contract on all the different Turing signing servers that it's been uploaded to, this address right here, or this turret right here will help us find those. And there's occasions where we may need to update or change that. And if we're going to update that, we use the contract address or the auth key address to grab those. And then the rest would be like our fields. The user will be just the person that we're assigning this contract to. That's going to be a lot of different people, but we'll just use one for ourselves as a demo. And then the signers will be when we upload to the turrets. Those will be the signers that we've uploaded to. And then the contract address, like I mentioned, we're going to grab right now. And that can be any address. We're just going to go ahead and generate a new one, and we don't even need to make this live, but we'll grab both the public and secret keys for that so that we know who owns this contract. And the rest we'll leave blank for now. And now we're going to go run that npm run contracts prod, which will take our filters. It'll actually take all of these contracts and compile them and spit them out into a contracts distribution folder, which is what we're going to use to actually upload. So it goes from this to this, which is obviously much longer, but it compiles all of Big Number and Stellar SDK and puts it all into a single default executable, which will be the actual contract that gets executed. So now we're ready to upload. We'll go to Postman for this. We're going to upload this with our upload contract. So we're going to pull in 0 and 1. And this is going to be whatever we're setting in our turret. So those things will need to be the same. Ultimately, what you actually uploaded to is what matters. The turrets are ephemeral. You can change those, but it will be important because that's how we trigger others who are using this contract to know where to actually send requests to. So our first one is this 0 Turing signing server, and then the second one will be the 1. Right. And this is a form data. We're going to go ahead and close those just for a minute. We also have fields, which we'll be using. Select that file, which is from our desktop. Our Turing signing server, contracts, distribution folder, filter. The fields is this array right here. This is essentially, if somebody's running this contract, they will know how to actually fill in the details. So what kind of body will the contract be receiving? In this case, it's going to be receiving a XDR name with a type of string and the description, and then a rule. This must be a valid stellar XDR string. So we're going to go ahead and uncomment that, copy that, put it back in, and then we'll just go to Chrome window. And I'm going to do a JSON stringify on this. And then we're going to take this and encode it with base64. So this should be our field string, which will equal this guy right here. And this right here is what we're going to put in to our fields. Turrets is the same thing. We just take this string here with the comma separation between the different Turing signing servers that we'll be using. We'll follow this same pattern, other than we don't need to JSON stringify it because this is already a string. That right there is our turret base64, which should equal this guy right here. And that will be our turrets. The auth key is what we put in for our contract right there. This is what we'll use to sign updates to the contract. We'll use the signature for this public key to sign for updates in the future. And then lastly, we need a payment. To be able to upload contracts, we have to make a payment to the Turing signing server for whatever its run fee is, which we can get by calling get Turing signing server on this 0 Turing signing server, and it will show us what the run fee, or the upload fee, sorry, is. That's 10 XLM. So we need to make a payment from somewhere and sign it as a valid payment to this vault address, which is the Turing signing server vault address, for 10 lumens. So let's go ahead and do that now. We'll actually use this account. We'll just go ahead and fund that. And then we'll build a transaction with this new account that we just made for a payment of 10 lumens to this vault address. And then we need to sign for this with this key. And then this will be our payment to the Turing signing server to let us actually upload this contract. So at this point, we're all good to go. We'll just click send, and this will upload this contract to this 0 index Turing signing server. And it will respond with our hash, which is our last key here. This is the ID of the contract, which essentially all that's doing is just taking the file and getting a SHA-256 of it. So that we have some idea of what kind of contract we're running. The vault address, which we already used to make the payment. And here's our all-important first signer key. If we were to call this now, we can start getting signatures for it. It's not going to mean anything at this point because we haven't actually attached these signers to any account to actually generate payments for it. But you could start adding these signers to XDRs right now. It's just going to not be all that helpful. So we actually want to upload this to our one index. So the other Turing signing server that we've uploaded this to, this is obviously going to fail because this payment has already been consumed. So we're going to need to go and generate a new payment. So we just go back to build transaction and sequence bump that. All the signing stuff will stay the same. And we've got our new payment. And this will upload it to the second Turing signing server that we're using. At which point we will be all ready to start using this Turing signing server. All right, we've got the hash, which we already have because that's the same hash because it's the same file. So the only thing we need to copy is our additional signer key. So now we've got all the signers. We've uploaded it to all the Turing signing servers that we need. So now all that's left to do is actually add these signers to some user account so we can begin to filter that account off of the contract that we've created. So if let's actually go ahead and generate a new user. So this will be our user account. We'll go ahead and give him some test network lumens. So at this point, obviously, this account can do anything because it hasn't attached this contract. So the first thing we need to do is add these signers as signers for the user account. So we'll go ahead and build a transaction which begins to add these additional signers. We're also going to set master weights to 3, 3, 3, and 3, and then give additional signers, these two new signers, a weight of 1. And the master weight actually needs to be 1 as well. It doesn't have to be 1. Again, it's probably a good idea because otherwise this really isn't all that useful. Oops. That's our signer, and this is our signer. If you leave it at 3, so right now we've got this guy's got a signer of 1, this one's got a signer of 1, a weight of 1, and then our master key, this key here, the user key, this BZU here, will also have a weight of 1 so that these thresholds for actually making a payments can be reached only when all 3 signers sign for a transaction. If we leave the master as 3, the master can still make payments or do anything on its account. It doesn't need the other signers. So we're actually going to set that to 1 so that the user is incapable of making payments unless it gets signers for any given transaction from these other two signers, which are our Turing signing server signers. We will submit this transaction. We need to use the user secret for that. And now once we submit this, this account is locked down to only being able to submit transactions when it gets signatures from itself and the other two Turing servers. So these Turing servers together cannot do anything without the user, and the user can't do anything without the signers, and these signers are locked in through the Turing signing servers from our contract that we just uploaded, which has this hash. So now we're going to go and actually run this contract. So if we look it up, let's actually look that contract up first, just so we get some sense. We'll use the 0 for that. We get the field. So the field says we have to use a name of XDR. It needs to be a string, and it needs to be a valid transaction envelope, and doesn't have anything about the payment of 100 lumens. That might have been nice to put in the description, but so that means when we actually go to run a contract, we're going to run this contract, and our body is going to include an XDR with a payment from this account. So let's go build our transaction, bump the sequence, and we don't need to set options. Now we need to make a payment. We'll just make a payment to anybody. It doesn't really matter who. We'll just make a payment to this contract address. Why not? For native assets, and let's just go ahead and do 100. Now this obviously has not been signed. We're going to need this user signature, but first I would like to collect the Turing signing server signatures first. So let's go to Postman, put in that XDR, and send that off. And that should return the XDR, which it will now have fees attached to it, along with the signer address that we already attached, and the signature for this XDR. So this is the signature which we would attach to the XDR. And if we do that, you'll have one valid signer for this XDR, which obviously we need 3. So we need to get it from both the 1 index as well as the, looks like we got it from the 1 index first. If we call it from 0, we're going to get the same XDR with a different signature, the signature for the 0 index Turing signing server. And so we would need to take both of these signatures and attach them to this XDR, which is what the collation contract. So run collate with the signatures of 2. So this is going to look up that Turing signing server when we uploaded a contract with our turrets. It's going to look at this turrets endpoint and say, who should we call to return signatures for this contract. So let's go ahead and run that. We'll say we need 2 signatures for this contract, and the body is the same XDR. Go ahead and send that off. That's going to run to both the 0 and the 1 Turing signing servers, grab both of those XDRs, put the signatures for both of those onto this XDR, and return just that XDR. So if we were to inspect this XDR, we can see we have the 2 signatures attached. We have a payment that we originally attached, as well as these 2 fee payments to the Turing signing servers, which were used to grab these signatures, which is all fantastic if we attach our signature to that. So if we actually say sign this transaction, let's import that again. We've got 2 signatures already attached, and we need to add 1 more. So let's just go ahead and try and submit this. It will fail because we don't have enough authorization. We actually still need 1 more signature. So if we go back to our user and we grab our signing key and we attach that signing key, we sign the transaction and we go to submit it. We've got our 3 signatures now. And when we submit that, it will make that 100 XLM payment to this address here. Fantastic. Let's show this same flow, but this time we're going to go over our limit of 100. Grab that XDR again. Go to Postman. We'll run the contract on the 0 index first without the collation endpoint, just to show what the response looks like. It's going to see that it's over 100 lumens and reject the request. It's not going to sign for this XDR. It won't give a signature, and the same thing obviously will happen on both fronts. If we try and run the collation endpoint, it'll return that same error. So we're only able to sign for requests that match the filter. And so now this account is effectively locked down to only being able to process requests for payments of lumens at or below 100 XLM, which is fantastic. And just like that, we've created and uploaded and are able to run a contract on a Turing Titanium server.